So Kit, are you ready?
Yeah.
Great. Okay, so hi, my name's Alice. I've worked at CAT for about coming up 2 years now on this project called Zero Carbon Britain. I started as research coordinator, so we had a team of about 6 researchers working here at the Centre for Alternative Technology, and I was kind of making sure that all of the bits of research that they were doing was kind of pulled together in one whole. And I did that for about a year until we published a new report, and now I work as communications officer, and I get to tell people about it, which is much more exciting. So I get to talk instead of sit behind a desk looking at spreadsheets. So what we'll do is basically we'll run through the presentation, hopefully take less than an hour, and then we'll do some question and answers at the end. So if you've got anything that you don't understand, or if you've got anything that's kind of like a burning question in the back of your head, then you can just ask me at the end and I'll do my best to answer. So Zero Carbon Britain is a project that runs at the Centre for Alternative Technology. It's been running for about 6 or 7 years now. When CAT started, it looked vastly different from it does today. This is CAT in 1973. It's a disused slate quarry in mid-Wales. And this small group of idealists decided that this was an excellent place to set up home. I don't know why, because they were actually aiming to be completely self-sufficient. And I'd say if you want to grow your own food, a slate quarry is not the best land. Anyway, they managed it. They also managed to build their own homes. So this building's actually still on site today. It's called the Whole Home. And it's actually still one of the most energy efficient buildings in the UK. I mean, according to the people who've lived there, it's not one of the nicest places to live. The walls are about yay thick, and it's got triple or quadruple glazing, and as you can notice, the windows are very small, so it's quite dark. Thankfully, architecture's come along since this building, and we've got things like the Wales Institute for Sustainable Education that we're in today, which is, even though we've got most of the things closed around here, much, much lighter and a much nicer space to be in. They also provided all their own energy at the beginning, so very, very early wind turbine here that was set up. And they also talked about storing energy, because we all know that it doesn't necessarily, when we take our energy from things like the wind and from the sun, we don't have them all the time, so sometimes we need to store that energy ready for when we need to use it. So this is a really early heat store that they made, which is basically just a big underground sort of bath of water. And you heat it up when you've got excess energy, and then you use that heat when you need some, when the wind isn't blowing and the sun isn't shining. So at the end of about 4 to 5 years, that group of individuals who lived here at CAT published a report, and it was called An Alternative Energy Strategy for the UK. Basically, at that time, people were really concerned about peak oil. So they were concerned about our main source of energy running out. So they decided that we needed to be doing things differently, hence the renewable energy, hence the energy efficient homes. And this is basically what they detailed. So they said we would decrease how much energy we would use, employing energy efficiency measures, and we would get that energy from different sources. That was their solution. Today, CAT looks quite different. We mainly focus on education now, so we've learned a lot over the last 30 or 40 years of basically practicing and trying things out and seeing if all of these technologies work. We're actually sat under this roof here, so we're in this building. We do things like run kids' activities in the summer. We run short courses in sustainable building techniques, things like forestry, sustainable agricultural practices. We do lecture theatres like this, sort of lectures. We run GSE, so we run the graduate school for the environment here at CAT, so we've got some master's courses that we run, which are kind of a mix of like learning like we're doing today and here, but also getting your hands sort of involved in what's going on. So this is our new biomass boiler. Get people involved in all sorts of different technologies, trying stuff out themselves, learning how they work. Sustainable building methods, straw bale building, can't really see that very well here. And we also run some architectural programs. And they go from all the way from making models like this about the kinds of things that people want to design to actually building them. So this is a bird hide that's actually in the forest that CAT owns just across the road in Pamperthorpe. And I'm telling you a bit about this because that's kind of the root of where this project Zero Carbon Britain comes from. The first report that was published, we're now on our third, was actually sort of bringing together a lot of the stuff that master's students here at CAT had learnt and had researched themselves into one publication. So we really at that first stage, the first couple of reports, really relied very heavily on what people were actually currently learning here at CAT. Now, as I said, we've just published our third report. It's called Rethinking the Future, and it's available free to download at this website here, or you can buy it from us if you really want to. So why do we do zero carbon Britain? So I mentioned that previously people were very concerned about peak oil, and I feel like that situation has changed somewhat. I think the thing that we're now mainly concerned about in terms of environmental stuff, like climate change. And this is just something that represents the kinds of things that we might see in the future, that we're seeing now actually. And I'm not going to go into this in a lot of detail because basically I've spent the last 6 or 7 years of my life looking at climate change. My background academically is in climate change, and quite frankly I find it quite depressing. Which is one of the reasons why I came to work here at CAT, because I get to talk about the solutions. I don't want to go into how dark the future looks. I want to look at the kinds of futures that we could have if we made the right choices. Because where we're heading is not pretty. By the end of the century, we're looking at, if we were just carrying on as usual, if we just chose to completely ignore climate change as an issue, we would be looking at somewhere like about a 4 degrees C temperature rise on average across the globe, and all sorts of different associated changes with that. Thankfully, the governments that we have today all get together and they've decided, no, we need to do something about this problem. It is a very serious problem, and we need to cut our greenhouse gas emissions that are contributing to this problem. And this is where it gets us. So even with current emission pledges from countries across the globe, we're still looking about 3 degrees C temperature rise by the end of the century. So we've not really made that much of a dent on this issue. Where we need to be heading is below this line, this 2 degrees C threshold. There are still lots of impacts associated with 2 degrees C change in temperature by the end of the century, but we think that the planet is basically still livable under that boundary. And if we look at the kinds of things that we need to be doing to get there, we've got these two here. Sorry, you can't really read the second one up very well. It says low emissions with net carbon capture post-2050. So that's basically ramping down our emissions, and then after 2050, we're not only not emitting any greenhouse gases into the atmosphere, but we're starting to suck it back out of the atmosphere and put it somewhere else. This bottom line is a global sudden stop to emissions in 2016. So the year after next, no one emits any greenhouse gases. And these are really vastly, vastly different scenarios from the kinds of things that we see coming out of our governments today. And that's why we do this project, Zero Carbon Britain. Basically, we look at the problem like this. There's lots and lots of furious activity happening over here within a politically realistic sphere. This is where we get in the UK, a very, very good target, strong in comparison to lots of nations, but still not good enough. There's 80% reduction by 2050 in our greenhouse gas emissions. Lots and lots of furious activity. Everybody is working on this side of this gap, and ZCB sits itself on the other side. So it's saying, from a physically realistic point of view, if we talk to climate scientists and we say, what are these kinds of things that we need to do to be able to stay below that 2 degrees C threshold in climate change, what does this world look like? I mean, where are we heading for? Is it vastly different from today? What kinds of things need to change? I mean, can we still do the things that we're used to doing at the moment, or do we all have to live, go back to the dark ages? What does this world look like? So what we do in ZCB is we make, this is my sentence that I use to describe the entire project, a technically robust scenario in which the UK has risen to the challenge of climate change, which I like because it sounds positive. But what actually means is that we have to make sure that all of our sums add up. So all our greenhouse gas emissions have to equal net zero, and we have to be able to run on net zero into the future. Our energy supply and demand have to meet each other, because we want to do the same kinds of things that we do today. And we have to use only the land that's available to us. We can't use more land than we've got. And because we're based at CAT, and because we've been doing research into renewable technologies for the last 40 years, we're going to do it on 100% carbon neutral and renewable technologies. And those technologies have to be available now. That's because we have to act on this problem now. There's no point waiting for someone to invent something in 20 years and then employing that. We need to be acting right now. So what I'm going to talk about is basically how we get from this, which is basically our greenhouse gas emissions today. You'll see there's quite a lot of them in total, most of them from energy, some from non-energy processes that are like how we deal with our waste or how our industry functions. And then there's a block here to do with land use, which actually has two sides to it. But I'm going to talk about how we get from this picture today to this. This is our net zero scenario. This is our greenhouse gas emissions that is technically feasible through ZCB. We've done a couple of bits of new research, as I was coordinating, is how we keep the lights on with the renewable energy system. It's that energy storage question. When we've got wind not blowing, sun not shining, how do we make sure that we can still turn the lights on? How do we make sure that we can still keep our homes warm? And the second question, which was, can we actually improve our diets and lower greenhouse gases? Because when we focus on this land use aspect, we actually find that the vast majority of the emissions from land use come from agriculture. And as I said, it's a bit of a mixed bag with land use because we've got emissions on this side, but we've also got some carbon capture. So our land systems in the UK are currently actually taking some carbon out of the atmosphere for us and storing it, which is great, but you can see that it doesn't in any way balance this large amount of emissions on this side of the picture. And with this focus on land use, I have to kind of just couch this in the sort of surrounding picture of ZCB, and I do actually have to talk to you about the energy system because we find that these three things are completely linked. Land use is excellent. You'll find in lots and lots of scenarios that talk about decarbonisation that they're purely energy scenarios. They just talk about our energy systems. And we find that really interesting because land use is actually the thing that ties everything together in ZCB. These arrows should probably actually go both ways because our land use has an impact on greenhouse gas emissions and on our energy systems. So I'm very briefly going to take you through the energy system in ZCB as an introduction to the land use and why it's so important. As I just said, the majority, but not all of our emissions come from energy, so it is a very important part of our country to deal with. And that's because we burn a lot of fossil fuels, basically, to produce how much energy we need, and the amount of energy that we need is a lot. We think we can reduce the amount of energy that we need, again, based on the kinds of things that Kat's been looking into over the last 40 years, energy efficiency measures. In industry, we go through sector by sector. For example, in industry, we don't change the amount of energy that we use in the UK very much, but we do change its form. So in ZCB, we electrify as much of our industrial processes as possible, but there are some processes that we can't use electricity for. We're electrifying systems because we want to produce our energy from renewables, right? And renewables only produce electricity. So we want to try and use as much of that as possible. But we have some dependencies here in industry on biomass and synthetic gas and synthetic liquid fuels. In our buildings, we can reduce our energy demand really drastically. And that's basically because we have a ridiculously terrible housing stock. They're cold, drafty, leaky, we don't have good insulation, we don't have double glazing on most of our buildings. Just by doing most of these really unexciting things like insulating your loft. And again, this last part, employing heat pumps allows us to electrify our heating systems. So we can reduce that energy demand right down in buildings. We can do the same kinds of things in transport, in fact. We can change the way that we move around the country, we can reduce the demand somewhat as a result, and we can improve the efficiency, again, largely through electrification. If we electrify our transport systems, we can go further for the same amount of energy. Not planes. Unfortunately, we can't electrify planes. That was very well timed. Very well timed, because my next slide is about that. So, electrifying our systems such as cars and trains is really good because electric cars, for example, go 3 or 4 times as far as conventional petrol diesel cars for the same amount of energy. So it's like free energy efficiency if we electrify those systems. But those planes we can't electrify yet. That means we've got a significant demand here for different kinds of fuel. And although we've reduced our energy demand by 60% in our scenario, it's still quite a lot of energy that we need to make. Thankfully, we live in actually not just one of the windiest places in Europe, but one of the windiest places in the world. We have a huge wind resource in the UK, and we should be making much more use of it than we are today. So in ZCB, that's basically what we do. We have a very heavy reliance on wind energy as a result because it's our strength in the UK. But we do have a lot of other different types of renewable energies that we can employ. In fact, in the UK, we have an abundance of them. On an annual basis, we have more energy than we need for our reduced demand in ZCB. So we don't have to maximise all of these resources in any way. And we can use those to meet the demands that I just talked about, those reduced demands. And this is the question that we looked into this time round, and it's important for the land use aspect you'll see right at the end of this, bear with me. Can we keep the lights on? So we built an hourly energy model. Basically, we took loads and loads of data, wind speeds, temperatures, solar radiation data across the UK, covering this 10-year period, each and every single hour. So for nearly 88,000 hours, we've got data representing all of those different things. And this means that we can do stuff like this. So if we were to, for example, put an offshore wind farm here and an offshore wind farm here, given that data, given the data that we've got on wind speeds, we could see exactly what the output was every single hour over that 10-year period. And we can do that for wind farms anywhere offshore around the UK. And we can do the same thing for onshore wind, and we can do the same thing for solar. So we build up basically an hourly profile of what all of our renewable energy systems in zero carbon Britain would be producing. We can do the same things with our electricity demand. As I said, it's a higher electricity demand because we've electrified our heating and we've electrified our transport as much as we possibly can. You can see here actually that it's really the temperature dependency that makes the difference. So you've got this last few days where our energy demand is higher than the previous few days, and that's because it's colder, so we need more energy to heat our buildings. So we match these two things up, and we go, unfortunately, we have some areas where there's a direct match, where we've got enough energy to supply what we need. We've got some areas where, hey, we have a surplus, so we've got more electricity than we need. But there are also these crucial areas where there's a shortfall. So in these gaps here, at that particular point in time, we're not producing enough electricity in the UK for our demand, for how much we need to do the things that we want to do. And we can employ this amazing system here to fix that problem, to make sure that we have a reliable energy system. What we do is we take this surplus electricity, so at times where we're overproducing electricity, we run it through electrolysis systems which basically take water, H2O, and split it into hydrogen and oxygen. Lose the oxygen, it's not important to us. Heat the hydrogen, and we use biomass. When I say biomass, you understand what I'm talking about. Biomass can be anything from food waste and agricultural waste to specifically grown crops like grasses, short rotation coppice, short rotation forestry, some nods here, great. So biomass, right? It's a carbon-based thing like we are. So we're taking the carbon from biomass and the hydrogen from electrolysis, and we're basically making synthetic hydrocarbons. And these hydrocarbons, chemically, are pretty much the same as the fossil fuels that we've got today. The difference is that our electricity is produced renewably, so we're not emitting greenhouse gases. And as long as we have a sustainable source of biomass, that is, for everything that we cut down, we replant afterwards, over a period of time it's carbon neutral. And we can produce these synthetic liquid fuels and synthetic gases that not only cater for those demands in industry and transport mainly that we can't electrify, but also provide us with some gas to burn in backup power stations. So these gas power stations are similar to the ones we have today in the UK. Actually, there are some of these power stations that are built elsewhere in the world. They're a bit specific because you have to be able to turn them on very, very quickly. Because we need a very, very responsive system to deal with these ups and downs here. So you can see this is how it plays into this sort of larger spaghetti diagram here. But you can see that this dependency on biomass is really large. So it's actually not only a very, very large source of energy, it's almost half that we're using from wind, for example, but it's also completely key to our energy system. Without this biomass, we can't fly, we can't use heavy goods vehicles, half of our industrial systems don't work, and we don't have a reliable form of energy. We don't have a reliable system that allows us to turn on switches as and when we want to, that allows us to keep our heating on when it's cold outside and the wind isn't blowing. So it's really, really crucial. And that's why we have land use in ZCB. That's why we think this is a really important part to model, because we need to know where that's coming from, right? And if we look at our land use today, you can see that a large proportion of our land is dedicated to food production, which is really important because we've all got to eat. But actually, despite about 70% of our land being used for food production in the UK today, we still import about 40% of what we eat. You'll notice that I'm just going to highlight here, and you'll notice in the next few slides I highlight this quite a bit. A large proportion of our agricultural land is dedicated to livestock. That's not just grazing land, but that's also land that's cropland that's used to grow crops to feed the animals so that we can then eat them. Basically, there's not much space for biomass in this system, especially the amount that we need, which is quite a lot. And if we look at the greenhouse gas emissions from land use, as I highlighted earlier, where do they come from? Yes, mainly agricultural. A couple of things to highlight here. There's some to do with land conversion. So in the UK, when we convert land, when we cut down forests, for example, or when we transfer grassland into cropland, then we lose the carbon that was either in the trees and the grasses that were living there or in the soil underneath. Cropland has the worst, the least amount of carbon stocks inside it. So every time we go towards cropland, then we're losing carbon from our soils. But it's only a very, very small portion of UK greenhouse gas emissions, and I've included world agricultural greenhouse gas emissions because we import so much of our food. And if you look in the rest of the world, there's a really, really large proportion from land conversion. In the UK, we've already converted most of our land to agricultural land, so there's not much left. Another thing to highlight is that a lot of it is nitrous oxide from soils. When we fertilise our soils, not just our croplands, but our grasslands as well, then not all of the nitrogen stays in the soil, it sort of degrades, gets eaten by bacteria, and then it goes back out into the atmosphere. So just through fertilising our soil, we're contributing to greenhouse gas emissions. And the third thing, again, large proportion of this in the UK and globally is down to livestock. And that's partially because of the amount of area of land required, but also because there's just so much direct emissions from them. You know, so you've got the manure associated with it, and you've got methane that comes from cattle and sheep. And if we look at the diet that we're getting from these food systems, not just in the UK, but from the food systems abroad that we rely on, it's not looking great. We had a nutritionist working on this, and I was quite staggered by some of the data that she came up with. 70% of deaths, not just in 2010, that's a pretty average year, related to our diet in some way. We're eating a lot of food, but we're not eating very well. In fact, we're eating too much food. We're also eating a really, really unhealthy balance of foods. If you look at this picture on the right here, the central circle is the balance that should be recommended. So we've got starchy foods like potatoes, pasta, bread, that kind of thing. High protein foods, not just meat and dairy products, but also things like soy alternatives, beans, peas, nuts, seeds, that kind of stuff. HFSS foods are foods high in saturated fats, salts and sugars. Fruit and vegetables, I hope you know what they are. But you can see from this diagram that basically our HFSS group is massive. In what we eat and drink, you can see where our health problems come from. We're also eating a little bit too much protein, but that's not necessarily a bad thing. The kind of protein that we eat might be. But we're definitely not getting enough fruit and veg, and we're not getting enough starchy foods. There's another problem associated with our food systems, and that's waste. It's been in the headlines quite a bit over the last couple of years, and this is actually 30% is just what we waste out of the food that's produced in Europe. The stuff that we consume in the UK, we waste somewhere between 30 and 50% of the food that we've got. That's not just us in our own homes, like throwing away stuff that comes out of the fridge, but that's along our supply chains as well. So can we improve our diet and reduce our greenhouse gas emissions? We make this model. We model about 60 different foods, which are things that you and I would eat on an everyday basis. It's actually based around the current UK diet, the kinds of things that we eat. And we look at how much emissions there are associated with producing each of those foods, how much land they require, and also the nutritional aspects. So what food group they're in, how much protein they contain, how much energy they contain, and whether or not we're adhering to about 10 sort of health recommendations that are given by like things like the NHS and our government here in the UK. Things like eat 5 fruit and veg a day, those kinds of health recommendations. And I'm just going to pick this up again. It's the livestock, animal-based protein sources versus the rest that we've got here that can really show you the difference. So this is modelling 4 different portions of protein. So you can see there's a different amount of each kind of food because you need to eat different amounts of them to get the same amount of protein. But you can see with this beef over here, our emissions are massive, especially in comparison to these plant-based protein sources. And also the amount of land that's required to give us that one protein portion is huge. The rule from animal-based protein and plant-based protein on land use is a little bit more complicated. But it's really that grazing livestock. It's the cows and the sheep. They're the problem in terms of land use. So we can link these things together, and using this model, it allows us to pick and choose different foods and sort of design a diet for the UK. We can design one that's healthier or more balanced than today, purposefully. She was a nutritionalist, she wouldn't let me design a diet that wasn't healthy and balanced. She said, if I'm going to recommend what people are going to eat in the UK, I am going to recommend something that is good for them. So we can design a healthy, balanced diet. We can make sure that it's low in greenhouse gas emissions, so we can choose more carefully with regards to our impact from a climate change perspective. And we can also choose foods that are suited to UK land. So we don't want to convert more land in the UK, or actually elsewhere in the world, to agriculture, because we're contributing to those greenhouse gases that come from land conversion. So we've got to stay within the constraints of the land that we've got. We employ the one techno-fix that we've got in the agricultural system, which is to use nitrogen inhibitors. So we put the nutrients on the soil, some of the nitrogen goes into the plants, and then we use nitrogen inhibitors that we've also put on the soil to stop some of the nitrogen coming back out again. That's the one techno-fix that we've got. I know it's a bit backwards because you put 2 things on the land instead of just getting one out, but bear with me. We reduce the amount of waste that we've got in our system, which is really important because it really reduces the amount of stress that we're putting on our land system and overall the amount of food that we need to produce. As does eating only what we need. It's very important from a health perspective, but also from a greenhouse gas perspective and from a land use perspective. And the last thing that we do is we product switch. So this is what this graph on the right is about, right? Yes, on the right-hand side. So we've basically got, alongside those recommendations to do with our dietary balance, ramped up the amount of starchy foods that we eat, ramped down the amount of HFSS foods that we eat, and ramped up the amount of fruit and vegetables that we eat. Those are largely done from a nutritional perspective. This group, this is the high protein group, this is the problematic group from a greenhouse gas and from a land use perspective. So we make some quite big changes here. Decrease the amount of milk, decrease the amount of meat, and we up the amount of plant-based protein sources, basically. And this is kind of an idea of where we would get our protein from on a weekly basis in ZCB. So it's a compromise, right? It's not saying everyone in the UK go vegan, which would be way better in terms of land use and greenhouse gas emissions. We're saying let's just go halfway here. So we've still got 5 to 6 portions of meat, dairy and eggs in our diet every week. 4 portions of these alternatives, which could be something like corn or soy or chickpeas or beans and lentils. And we included enough milk for everyone in the UK to have the same cups of tea and coffee that they have today, and to have milk on their breakfast cereal if they want to. So there's still a fair amount of animal produce in our scenario. It's just that we eat so much today that we can get away with a lot less and still have a significant amount in our diet. And these kinds of things reduce the emissions from livestock by from agriculture by 73%. As I said, if we all went vegan, that would take us further, but we think that's quite a big ask. So we're going halfway. It also means that we've got a better diet in the UK, so that's our old average diet today. Purposefully constructed a much more balanced diet in ZCB for us on average as a UK population. And crucially, we use much less land. So this is the situation today where we use about 70% of our land to produce that should be about 55% of our food. And this on the right is what we do in ZCB. So we've actually got now about a third of our land. But we are producing 85% of our food, so we're much more self-sufficient just through making those dietary changes than we are today. It also means that we have some land spare to play around with, which is why land use is so crucial in ZCB, because it allows us to do two very important things. The first of which is recognising that it's grassland. In order to do these two things, we have to recognise that it's grassland, right? So taking in mind that land conversion thing, we don't want to convert it into something that will lose carbon for us. So we need to respect that it's grassland now and choose things that we can do with it that don't convert it in a way that loses carbon from the soil. One of those things that we can do is that we can grow biomass for our energy system. Again, we have to choose the kinds of things that we're growing carefully to make sure that we can grow them without losing carbon from the soil. In fact, some of these things growing on grassland will actually increase the carbon stocks on soil over time, but a very small proportion. So that's where we get our biomass for our energy system. We can grow it all here in the UK. And why do we choose to grow our own? I just kind of slid this in because I think it's an important point to make. We could, for example, just say, hey, no, let's just not change our diets in the UK and change our land use systems, and let's just import our biomass from abroad, right? Let's just buy it from someone else. The thing is that biomass is tricky. It's tricky for a number of reasons. One is that it isn't always carbon neutral, and there are a lot of organisations in the UK that are very worried about the direction that our government are going in at the moment with regards to biomass. It's not always carbon neutral because you have to basically do two things. One, you have to make sure you're putting it on the right kind of land, that you're not, for example, chopping down a rainforest that's not only great and biodiverse, but is also full of carbon and emitting that carbon as a result. But you have to make sure that it's that thing of like every time you cut something down and use it for your energy system, you have to plant it again. Otherwise, you're not carbon neutral. That has to be your full life cycle. You can't stop halfway through. It can compete with food. So in ZCB, we have enough space to do biomass and the vast majority of our food, but there is a real concern, and it has happened. There is evidence to show that actually biomass growth in some areas of the world takes away places where people grow food locally for their own use. It can destroy natural habitats, cutting down rainforests, and also have impact on cultures and societies around the world. That's why we grow our biomass at home in the UK, because we think it gives us the best chance of good regulation to ensure that it's carbon neutral. In the UK, it's not competing with food, and we've decreased our food imports, so we're having even less impact abroad than we are currently. So that's our less impact overseas in general because of our land system change. And we don't destroy natural habitats in the UK, so we're not cutting down any of the forests that we currently have in the UK to enable us to grow biomass. So this is how much land that we had spare already in our ZCB scenario. Even once we've grown the biomass for our energy system, we still have some space. And just going back to this diagram here, I'm just going to focus on the carbon capture aspect. So in ZCB, we have reduced this top bar pretty much to zero in our energy system. So we've got that down. Our non-energy processes I haven't gone through today, but there are some techno fixes that we can employ that reduce those emissions. But again, given the technology that we have available today, we can't get those to zero. Similarly, you just saw in our agricultural systems, we only reduced those emissions by 73%. So we've still got some emissions in our scenario. And basically what we need to do is that we need to ramp up this carbon capture aspect to be able to balance out the residual emissions. So that every year in our scenario, yes, we are still emitting some carbon into the atmosphere, but we're drawing down the same amount of carbon out of the atmosphere and storing it somewhere. That's what gives us this carbon neutrality, that gives us net zero carbon in our scenario. And land use is where this comes from. Today, some of it is from forests, so planting new forests, and actually forests that have been planted a while ago still draw down a little bit of carbon. As the forest gets older, you draw down a lot less carbon. Grasslands too, actually, the more natural a grassland, then the better it is at capturing carbon, roughly speaking. And wood products, so things like buildings like this, where we actually have wood in the building, is a way of storing carbon. Trees made of carbon, we cut it down, we put it somewhere, and we replant the tree. And we can enhance these systems because we've got that land that's spare in our scenario. What's important about all of these systems, so these are different methods of capturing carbon that are natural, okay? So these are sort of like natural, proven, long tried and tested methods that we know work and will work into the future. What's important about these things that makes them a little bit complicated is that they not only capture carbon, but they also emit carbon at the same time. All we have to do is basically make sure that we're using these systems in a way where the blue arrow, the carbon that's captured, is bigger than the red arrow, the carbon that's emitted. So for example, in forests that we leave, as I just said, when we plant new forests, obviously there's a lot of growth there, so there's a lot of carbon taken in. There is still some stuff that comes out from bits of the tree that dies that go along, but as the tree is getting bigger, it's storing more and more carbon, and that kind of levels out after a while, but it keeps going for quite a decent period of time. Same kind of thing in harvested forest happens, but then we take the wood out and we put it in things like the seats that you're sitting on, and then we replant the forest. So we've got another carbon store there, and actually at the end of the life of that seat that you're sitting on, we can choose to do a couple of things. So we can choose to make it into biochar, where's my word like, here, biochar, and we can put that into soil, which helps us keep the nutrients in the soil. Or we can do this thing called silo storage, which is actually just like a better way of doing landfill. We don't have very much of this in the scenario, but we do actually bury quite a lot of wood products today, and it does hold carbon for us. So this is an option. The last thing is to do with soil. So the one on the left are just your regular common garden soil, and it's to do with the way that we do our agriculture. So we can have better agricultural practices that means that there is more carbon being taken in by the soils. Not a huge amount, because we're still using them for agriculture. The one on the right is a real diamond, peatland. Peatland is great, it's my new favourite thing. So peatland is like the first part of recreating fossil fuels. So at the moment, we've just been like burning all of this stuff that was originally sort of peatland, but over like thousands and thousands and thousands of years got created into fossil fuels. So we're burning it, we're burning this massive store of carbon, but we can start making it again by looking after our peatlands, basically re-wetting them. We've got quite a lot of peatland in the UK for the amount of land that we've got, but we're not treating it very well. If we restored it to its normal state of being, then it would keep on capturing carbon for hundreds of thousands of years. It's a very small amount of carbon every year, but it would keep going. And we would very, 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 very gradually be recreating those fossil fuels that we've been burning so quickly. Very gradually. Burning fossil fuels for roughly 200 years, peatlands back into fossil fuels, hundreds of thousands, millions of years. So it's a very long process, but it's the first step. So that's basically these systems are the things that we use in ZCB to capture that last amount of carbon, to balance out those emissions that are still in our scenario. Basically, restore 50% of peatlands, we could do more. Double the amount of forest area that we've got in the UK. Some of that we harvest, so some of that we use as your wood products, and we put in buildings and we make furniture out of. But some of it's just natural forest, so some of it's increasing biodiversity as well. There's more space for animals, more space for different kinds of plants, more space for us to go and want to have a wander in the woods. And that's basically it. That's land use tying together our systems. It's producing food for us, it's producing energy for our biomass for our energy system, and it's supporting natural systems that capture carbon for us to be able to make that net zero scenario. And that's the story of how we get from the picture today to this net zero emissions. So these are our much reduced emissions on this hand, and then this is the carbon capture that's enhanced. You can see that it's actually not very different, despite that large amount of land that we're using to do that. Because those natural systems don't work fast, you know? They need a lot of area to be able to capture carbon. But it's really important. That's the only way that we get to net zero, using currently available technology. But we do show that it's possible. We also showed that it's possible with a reliable 100% renewable or carbon neutral energy system. We can provide a healthy, balanced diet for people in the UK that's low in greenhouse gas emissions. And there is enough space on our land to produce these three things. We don't have to gamble on future technology. We can do this now if we want to. And I don't think there are major impacts on quality of life. Yes, there are things that change, but largely speaking, it's a bit of a mixed bag. So actually, from my perspective, if I compare the future that I looked at for the last 6 to 8 years of my life, from a climate change perspective, and this future, then I am going to argue with you until the cows come home, no pun intended, that this future is better. There is a potential for job creation. It does help us adapt to changes that we know are going to happen. We are already seeing changes to our weather systems as a result of climate change. There are more floods and there are more droughts, for example. Planting trees is one way that we can actually help mitigate both of those things. So there are some actions in ZCB that help us adapt. There's a better outlook for biodiversity. We're no longer using so much of our land in the UK for our own gain. There is more space for natural systems. And I'd argue that it improves our health and well-being. Yes, more healthy, we all eat better, and also we do more cycling and more walking. Great. But I also think that just having a positive future basically gives us a higher well-being. Being able to know that our future doesn't have to look like this. Okay, so it might not look like this either. It's not necessarily like super high-tech and like flying through the air on space rockets, I don't know. But it's not like this, it's not living in mud huts. We don't have to go back to that kind of living. In fact, my positive future looks a bit more like this, which is strangely familiar. So in some respects, it's not very exciting because, you know, it's not like high-tech and super swizz and stuff in the future. But it's also kind of quite comforting because this kind of future, even though it has a lot of changes associated with it, is pretty familiar to us. We actually still do most of the things that we do today. Thank you very much for listening, and if you have any questions, I will be very happy to answer them. Thanks very much.